by Elias Naur is The Gopher's Guide to Mobile Apps. Thank you.
Now, let's say that you are about the same kind of Go programmer as I am, which is one that has discovered and found Go, the programming language, to drastically increase the productivity and the fun you're having while programming your programs. And let's also imagine that you think that Go is so wonderful that you would like to use it for all of your programs, every program that you write, being it a command line utility or another kind of program. And let's imagine that you are a backend programmer or a systems programmer or an infrastructure programmer or a title like that. If that's the case, you will have seen probably today and yesterday and everything and in the last few years that the possibilities of using Go in your job or in your projects is increasing and increasing and increasing. There are more and more libraries available, and Go is appropriate for more and more kinds of applications. The one missing part, I think, is UI programs. And more specifically, it's for when you would like to write mobile apps. So apps for your phones and tablets. And in that case, you're pretty much normally locked into whatever the platform provider gives you. And in the Apple case, it's Objective-C and Swift and the UI libraries for that platform. And for Android, it's almost the same, except it's an entirely different language, which is Java, and the UI libraries on Android. So even if you wanted to write an app and could live with writing it in a language which is not your preferred language, you would still have to write it once for one of the platforms. In my case, I know Android best, so I write it in Java and finish it in Java and create all the UI views and everything else. And then when you're done, you have to start all over in another platform. So if I was so unlucky to write both of the applications, both of the apps, the same app, but still on two different platforms, I had to rewrite it all over. And there's almost nothing else that I like least than writing something twice. If you're lucky, someone else will write for the other platform, so you're on Android and someone else is on iPhone. But still, the app has to be written almost from the ground up again. You can reuse some screens, some design work, and some thoughts about how to architecture your application. But more or less, you have to write it from the bottom up. And this is where Go Mobile comes in. And this is why I work so much with Go Mobile and try to make it even better than when it started, is the promise or the lure of being able to write your application once and for all.
Try to just put it just a little.
So with Go Mobile, there's a huge chunk of at least a non-trivial chunk of your application code, which can be written once in Go, and then you can share that library or set of packages, Go packages, between your applications, between iPhone and Android. And that's what brought me into it. I don't even like to write the UI code, the rest of the code, the thing that makes your click handlers and your display, everything that handles the UI. I don't even want to write that in Java or Objective-C. So there's a relatively new possibility in Go Mobile for writing everything. Also, the UI code as well in Go. So today I'm going to show you first how a basic Android application looks like. I know Android well, so that's what we'll do today. And I'll show you how to use Go Mobile to access a model, a Go model, where you have your data in Go, and you have your Java code to access this model and display it on the screen. And finally, I'll show you how to go even a little bit further and write that Java code in pure Go. So you'll have a finished, complete Android app that only runs Go. Right. So first, some history. Go Mobile started in 2014, and the foundations of it is relatively stable and robust. So you can write the first method where you have your core code in Go, and you have your Java code around it, or your Objective-C code. That's pretty stable, has been around for a few years. And some projects are starting to use it, some companies are starting to use it. The few I know about is the Go Ethereum project, which is the new digital coin / decentralized computer. They have written a client in Go, and to expose that to mobile apps, they're actually using the official bindings for mobile apps to Ethereum for this client is using Go Mobile. So they exported their Go packages with Go Mobile, and they show it. They make that available as a download for Android developers or iOS developers that want to integrate with Ethereum. And then I know about at least 2 companies using it for their both their Android and iOS apps. It's Zenly and TrackRef, and they use the traditional way, if you can call it that, of Go Mobile, where you have your core code shared between the backend and the apps, and then you have some UI layer code written in the native platform language. So a very basic Android app consists first of the build file. It's plain and simple, and you'll see that even if you don't use Go Mobile. It describes your dependencies and where you'll get those dependencies from, and details like what's your application ID, what's the minimum SDK version, and so on. So this is a very simple but complete build file describing how to build your Android app. And a small thing, I've enabled the data binding library, which is a nice way of not having too much boilerplate of UI code. But there's nothing Go specific in it. Next, you have your manifest. A manifest is an XML file describing all your activities in your Android application. An activity corresponds more or less to one screenful of information. In this case, we have one activity, we have one application, we have one activity inside that application, and it's the class name, the Java class name is main activity. And it's called basic1 when we see it on screen, on the Android screen. And then we have something that is more or less similar to your, if you come from the web world, you probably know HTML and CSS. Themes XML and styles XML in Android world is the moral equivalent of CSS code. So this is a very, very lightweight styling, but this is where you describe all your colors, font sizes, and more or less classes for your user interface. And then you have a description of your activity, the one screenful. It's more or less the same concepts as HTML. You describe it in XML. And in this case, we have only one view in our activity. We have a text view, which is simply a component that can display text. And in this very simple example, we're only interested in the last property down here, which is the text. What is going to be in this text label? And it's just the static text, hello GoLab. And finally, we have the Java code to bind it all together. It's an activity. You can see that by noticing that it extends one of the classes from the Android UI libraries. App Compat Activity is sort of a way to make Android apps written for newer Android versions to work on older Android versions. But in this case, you can simply you can think of it just as extended activity. So this is a class representing a screenful of UI. And the only thing it does is that it finds this XML file in Java, the one we had here, and expands it, and sets the content of this activity to this. It's more or less a HTML-like file. And the result is simple. A basic Android app with one activity, one display, with one text in it. So far, so good. If you want to use Go in your Android app, you have to do very few things. Back in the build script, add the GoBind plugin. The GoBind plugin is a part of Go Mobile, which integrates into Gradle, all the build systems that Android apps use, and make sure that all your Go code is compiled correctly, built correctly, packaged correctly, and included in the final app. And down here, you configure it. And the only thing that's required of you is that you tell it which Go package do I want to have included in the app. Then, finally, some Go code. In this case, I'm going to show you a screenful. We'll expand the simple Android app to be an account overview in a banking-like application. And to have an account, you can model it very simply by having a balance. The account type is your account, and inside you have the balance and the list of transactions that have been applied to this account. You can construct a new account, which is simply an empty one. The empty value is meaningful. And the transaction is the type that describes each and every transaction on this account. It's, again, not very surprising. We have the amount from the transaction, and we have the timestamp, the time that this transaction was applied, was committed to this account. And we have some helper methods defined to help the UI code, in fact. We'll see that later. We have a way on the account format balance method to format it, to write it, to convert your amount, which is a float 64, to something that can be shown in the graphical user interface. And we have a way to add new transactions, so we can actually do something interesting with the account. New transaction, adds a new transaction, sets the amount, and sets the time to right now. And finally, two other helper methods, one that can extract the number of transactions that is currently in the account, and one that takes one particular transaction out from the account. Still, very, very plain Go code. The way to use it from Java is to realize that GoMobile takes each and every of these types, the account type we saw earlier, and the transaction type, and converts it to the equivalent in Java. The account type is a struct, so it's converted to a class, and you can see it here. We use it by first constructing a new one. This is Java code. So you have to use the new keyword and then the type of the class, and then we can call methods on it. So each and every of those new transaction calls, in fact, goes down to your Go code, calls the new transaction method on the account. So this new transaction is the one that eventually ends up being called when Java code calls new transaction. So in this case, we've added two static transactions. And finally, we set up the account to our layout, to the HTML. We bind this account variable to the UI. And the way that works is that we have the activity XML that we had a few slides earlier, which only contained one text view with the static text hello GoLab, and expand it a little. We define a new variable, account, with the correct type. And we say that instead of having hello GoLab written, we simply write whatever account.formatBalance returns us. So as you would expect, every time this UI is displayed on screen, it will actually call the account in Go, and call the method formatBalance, and it will end up showing the correct balance in your app. So this is the most simple way, the most straightforward way to implement Go code in your application. Now, we'd also like to show you. I'd also like to show you how to display the transactions, because this is just a simple text view. If you have lists and menus and all that in Android apps, you will have to write a bit more Java code to integrate that. For lists, for example, you have to use the Recyclerview. Recyclerview is a way to. It's a widget that makes sure that even if you have thousands of transactions in your account, but only 10 or 12 or 20 is showing on your screen, only those will be using resources to display itself. So you won't have thousands of text labels showing the amount and thousands of text labels showing the time. You will only have those 10 or 12. But to do that, you have to do some extra work. You have to set up this Recyclerview, and you have to set an adapter, which is the connection between each and every entry in your display and each and every actual transaction in your model. And a transactions adapter looks like this. It has to extend a certain class. This is still Java code, by the way. Extend a certain class. It has to define get item count, telling it how many total items are there in total. And it has to define how to create a new view that shows one transaction. And it has to have a way to take one of these views created and bind a certain transaction to it. So it's a bit complicated, even in Java. And finally, you have to have a transaction holder, which holds your transaction. All that is needed to just have a list of transactions. So we have the balance from before, and we have the list of transactions. In this case, there are only 2, but there might as well be many, many thousands, and you could scroll through them. So all this is very nice, but if you've followed the slides up till now, you've seen very little Go code. You've seen 2 pages of Go code, very simple Go code, and a lot of Java code to integrate, which is needed even if you had a pure Java application, to integrate your model, which is the account and transactions, with the UI code, with the UI layer, so to speak, which is text views and styling and so on. So a few pages of Java code just to connect 2 pages of Go code. So this is where the reverse binding mode of Go Mobile comes in. Instead of having your Java code or Objective-C code or Swift code calling into and manipulating your Go objects, your Go model of the data, you can invert that relationship and instead use only Go code and use the Java libraries, the Java SDK, and all the libraries available to you on that platform, use them directly from Go. And it works a bit like CGO, if any of you have tried to implement a Go program that had to call into C libraries. In that case, you will import uppercase C. In this case, you import uppercase Java. And then whatever comes after that specifies which Java package you're interested in. In my case, I have to have access to the Android OS package for the bundle type. This is an Android-specific type. And I have to have access to the app package to make a Go activity. Because the next thing you would like to do is exchange that main activity Java file with a Go struct, a Go type. And this is a Go type, Go activity. And by embedding this type here, you tell the Go Mobile, I want Go activity. When you're converting this to Java, I want it to extend this type, app Compat Activity. So that's very similar to the main activity we had that directly extended it in Java. Now we have a Go activity instead. And see the imports up here, and you can see the extension here. So we go back to the Android manifest and throw out the Java code, and instead we replace it with Go activity. So we mention a class directly from the manifest. So to the Android system, this is just pure Java. And it doesn't know that beneath your class is some Go code that actually drives things. And the final thing we want is an onCreate method that simply calls super and finally sets up the activity. And setup activity, yeah, okay, this is what you get if you just have this plain onCreate. A simple one activity application with nothing in it, of course. And then we'll replace whatever was written in Java. The first thing that we need is the UI view, the layout file. And we can do it almost the same way as in Java. We have here data binding at util, which is a Java class. And we have its method, its static method, setContentView, which is also a Java method. And we cast it. And then we are able to pull out the Recyclerview with findView by ID. Again, it's an Android method, nothing we have written. We set it up. We create the new account in Go as well. We add transactions to it. And finally, we have the transactions adapter binding the Recyclerview with your model, the account transactions, also written in Go. And it looks like this. We have the getItemCount, the 3 methods from the few slides back. We have the getItemCount describing how many transactions do we have. We have the onCreate view holder, which creates a new visible component to display a transaction. And finally, we have onBindView holder to actually take a specific transaction denoted by this position and display it. So this is pure Go code. And finally, the transaction holder holding things. And this is pure Go code. The same thing as last, with pages up and pages down of Java code converted to Go so that you have no Java code in this version. Same thing, balance, transactions, a list view, a Recyclerview for displaying lists, and simple text views for displaying just text. Now, you might wonder, why is all this thing necessary, all this trouble worth it? Because there are quite a lot of work to make an Android applet, and there are some frictions. The code for Go is a little bit more difficult to get right than the Java equivalent for UI. And the best example I have, other than combining two platforms into one and only writing the code once, is that you can take an existing Go code, Go library. The Go library ecosystem is expanding all the time, and more libraries are written. Or you could have your own project where you've written a huge pile of a huge amount of Go packages, or someone from your company has written it, and you want to use it for your apps. And the best example I can show you, where I didn't have to write a lot of Go code, is Bitcoin. Because, as you might know, Bitcoin is a digital currency. It's decentralized. There's no single point of failure or trust. But it also means that if you're participating in the Bitcoin network, you have to implement all the complexity of the Bitcoin protocol. There's no server to help you. There's no backend. There's no infrastructure that you can call. You have to write it everything yourself, or have a library that does it for you. And in our case, we're so lucky that at BTC, the package set, I would say, BTC Suite is a suite of Go packages that does all of this for you. It's a fully functional implementation of the Bitcoin protocol, the Bitcoin daemon, which is a node that participates in the Bitcoin network, and it's able to send and receive transactions. And it also contains a client for communicating with the entire Bitcoin network. So, let me show you what I mean. I have a demo that hopefully runs. This is the same thing as, just a minute. This is the same thing as the account overview demo I showed you earlier. It has simply been expanded to use the Bitcoin network instead. So instead of having an account overview with the balance in euros and transactions in euros, this is actually a almost fully functioning Bitcoin wallet, which has a Bitcoin address in it, and it has a way to show this address, and it has a way to monitor for transactions that goes into that address. The other thing that's missing, which would be easy to add but is not in this one, is the ability to send them out. But other than that, it should be fully functional. Let's just see here. Can everyone see it? Yes. So this is the balance. If you press this button, you get a QR code representation of the account. And the account number in Bitcoin is the thing you see written down there in the bottom. This thing starts with MP81 and so on, which is quite long, but it has to be long because it identifies your account. It's more or less equivalent to a bank account, which has a registration. I think it's for European, it's IBAN number and BIC number, which one for the bank and one for the account in that bank. In this case, it's just one number. And to make it easier to transfer to others, not to say, you have to transfer to MP81 and so on, you often represent Bitcoin account numbers with QR codes. And on this one is a wallet, a fully functioning wallet called Mycelium, which I didn't write, which is also participating in the Bitcoin network. And it is able to send and receive transactions. And to show you how little work is required because I can reuse this BTC suite, I'm going to show that how this wallet, which has nothing to do with Go, can scan this address. Like that. Scan the address. Now it has the address entered by QR code, and then I have to enter the amount. And our currency is milli-BTC, which is thousands of Bitcoin. And I can transfer, for example, 123 milli-BTC. And let's see if it works. Some guy in the audience, I think, is already transferring. It's a friend of mine. I placed him there, so it's his job. But let's see if it works from here as well. Yes, 123 transferred. So what happened here is this wallet sent out the Bitcoin transaction to the Bitcoin network. And the Bitcoin network works the way it does by flood filling the transactions to every node in the Bitcoin network. And one of the nodes is running on this laptop, but might as well run somewhere else. And connected to that node is this Android app. And the Android app tells its node to watch for this address, the address you saw earlier, there, and tell it whenever a transaction occurs that hits this address. And as you see, when our node on this laptop was seeing this transaction from Lars in the audience and from this wallet here, it can register it, display it, and update its balance. So, in summary, when should you use GoMobile? I think it's the most pertinent way to write your apps if you have a huge body, or at least a non-trivial body of Go code you already have, or you intend to write, that you want to export and use from both the mobile platforms. It's also very, very nice to avoid, even if you don't have existing code to use, like this in the BTC daemon example, that you can write things once and not having to rewrite it in another language, and you can get to write it in Go. The reverse bindings are cool, but I just want to say that they're experimental and new, so you might have varying levels of success with it up until now, but I've been using it at least for this toy demo and for a few other things, and it works reasonably well. And the very last thing is reference cycles. If you get to use GoMobile, make sure that you are aware that you have two languages. Even if you write everything in Go, there's always the Java language behind it, or the Objective-C if you're on iPhones. And to make that work, the references that crosses the language barrier are reference counted. So if there's a reference to a Java object from Go, or the other way around, there's a reference count taking care of that reference. So if you have a cycle, so a Java object referencing a Go object, which in turn references that Java object again, you have a reference cycle, and that cycle will not be automatically garbage collected, even though you're used to it in Go and you're used to it in Java. So that's something to watch out for. Yeah, that's about it.
Thank you. We have a couple of minutes for questions.
Hello. Great work. I have just one doubt. So I'm not sure how it works behind the scenes. So are you compiling like a binary, or are you transpiling? If you are like converting Go code to Java code, how do you work something like Go routines? Are you like managing threads, or?
This is not transpiling, it's compiling. So it's using, behind the scenes, GoMobile will take all your Go code and compile it for the platform natively. And then use the JNI. In Android, there's a JNI facility for calling native code, which is normally C code or C++ code. But in this case, it's Go code, calling that from Java. So you have, except for the language boundary, a barrier where you have to call across that barrier, everything else in your Go code works exactly the same as you would expect. So Go routines work, maps work, channels work, slices, and you have the lightweight threading model. So there are no one thread per Go routine or anything like that. So you have the exact same performance characteristics on a mobile, except that you're on an ARM device instead of a very powerful Intel CPU. So you have to take care of that. But other than that, you won't have any surprises in that way. So it's, to sum up, it's a library, a so file, a dynamic library, which is included as a JNI library on Android. And on iOS, the language Objective-C and Swift already compiles down to native code, to assembler code. And the Go code is simply appended to that, included in that. So it's the same thing over there.
Any other question?
What's the point to have reverse bindings at all? Because using it, you lose cross-platforming property. You bind to a specific language. You lose after completion, and actually you have to write in Java in Go. And you can't use this code on iOS.
It looks like Java because Java is from, I would say, one thing, I'll just see if I can find it. Yeah, so I would say it looks like Java because Java and Go both share the same heritage. It's a C-based language. That's the one thing of the one point of it. The other point is you get to write Go much earlier. So you already in this function you can use Go-like features like the colon assignment instead of mentioning your type. You can create your model classes, model types directly in Go. So I would say the best reason to use it is that you can hit Go much earlier. Instead of have a huge gob of Java code, you can be in Go land much earlier. But you're not required to do it. You can do it as little or as much as you want. And this may be an extreme example to show that you can go all the way to no Java. There's, of course, a whole line of nuances between no Go code and all Go code. And you can use the reverse bindings to access whatever is convenient. If it's more convenient to write it in Java, I think you should do that. So it's more of, it's a feature to give you some choice. So you don't have to write it in this way with Java and Go. Go. Yes.
So can we use build tags to build some Go files for Java, some Go files to iOS?
Yeah. I think I'll find the time to put this up in a public repository, and you'll see that the file containing this code is called app_Android, which makes sure that when the Go compiler compiles it, it only takes that file into account if it's compiling for Android. So for iOS, you would have app_Darwin, perhaps, or you would have a build tag called iOS you can use for that.
Are there other questions?
Hi, I was just wondering, are you only doing this so you don't have to rewrite code, or is there any performance benefits as well, being able to run the Go code on an Android phone as a binary?
Performance? What do you mean by performance?
So my opinion is maybe Java might not be as quite performant as like a Go binary when it's compiled. So can you leverage that for performance, not only so you don't have to not repeat yourself, but you can get performance gains?
Someone from the training session yesterday sent me a link of someone having problems with, I think it was a word matching algorithm, some Russian guys. And they had some problems writing it in Java for Android because it was simply too slow. So they rewrote it with Go Mobile in Go and had a huge speed up. But that said, I don't do this for performance. In fact, whenever you cross the language barrier, call a method from Java implemented in Go, it will be quite a lot slower than just a regular method call in Java. So I do it primarily to avoid rewriting code. And in case you have a significant backend code, you can actually share not just between the two mobile platforms, you can also share a lot of the code with the backend, all the RPC code, the protocol definitions, everything else. So that's by far the most interesting feature, because the Java compiler / runtime on Android is actually quite good. I think the Dalvik one was slow in some cases, but they have a new one called Art where they ahead of time compile all the Java code from your application to native code directly. So I don't expect much difference at all between the performance of pure Java versus pure Go, except perhaps for this example with the Russian guys. So it's only for avoiding rewriting in the context of your question.
No other questions?
So you said that the reverse bindings are still experimental. Do you have any information about, don't know, timeline, ideas about what's missing, how long it could take to reach a stable situation? How many people are working on it or something like that?
So, to be completely honest, the GoMobile parts that you, the old style, as I called it, where you have again the Java code and then the Go code you call, it's been around since more or less 2014. That's a lot of changes are happening to it, but the core of that is working quite well. The reverse binding came out of. I made those because I was frankly too tired of writing Java code. So that was more like an experiment for me to see how far could I push this slider towards the 100% Go, and it turns out you could push it all the way. But that said, I made it for the first version of this reverse binding was made for the .go talk in the fall, so that's only 3 months ago. And I had quite a few. This toy wallet you saw, the core code of that perhaps took 1 day to make, a few hours perhaps. But it still took me about 1.5 weeks to make it, just because I ran into smaller and medium issues with the reverse bindings. So it's more a question of writing enough programs with this to be certain that, okay, if so many programs exist that works well with it, perhaps my program would work with it as well. And that's why I've showed you the references in the beginning, because the thing, when you're not sure if you should commit to a new technology that you haven't used before, you have to have some references to gauge, to try to make certain that it will work for your case as well. So my recommendation is that you use your GoMobile old style bindings if you have a serious app, and then experiment with the reverse binding if you find them useful, and see how far you can get. So.
Thank you, Elias.